Alright, hello, welcome to Miss Brown's math class. So today we are talking about cross sections. Cross sections are two-dimensional shapes that we are getting out of three-dimensional solids. So a three-dimensional solid is a 3D shape, so we could be talking about something like a sphere, a cylinder, a cone, even something like a cube, a rectangular prism, anything that is a three-dimensional shape. Okay? So for today's lesson, if you have Play-Doh, this could make your life a little bit easier today. All right? So for today's demonstration, we will be using Play-Doh and butter knives in order to make our cross sections, okay? So first of all, we want to identify what type of three-dimensional shape is this. So it has a circular base, and then the side looks more like a rectangle. So based on that description, we'll go with the cylinder. Okay, everyday shapes around your house that may have this be like a can of soup or a can of soda. So now, as far as what a cross section is if I was to cut this shape, so if I were to take a knife and cut this shape, it's just Play-Doh. Okay. Looking at that now, what shape do I get? Okay, it just looks like a circle. Okay, so the cross section is the two-dimensional shape that I get from it. Okay, so going back to what we just said, a cross section is a two-dimensional slice of a three-dimensional solid. So in this case, our cylinder became a circle. Okay? Now, the same cylinder that we just had I put that back together, okay, it's Play-Doh, rebuild it. Had I cut that cylinder the other way, it could become a different shape. So now you're thinking to yourself, what could that cylinder become if I cut it sideways? Okay. So you can think about this as being like a sub from Subway. Okay, oops, a little bit of it came off. More or less, what shape does that look like? No, a little bit of it got melted off there. Okay, that should look like a rectangle. And if you think about it, the side of a cylinder looks like a rectangle. Okay, if you look at this cylinder and you ignore the circle up top, doesn't that look like a rectangle? That's essentially what we're saying. We're saying we can look at the cylinder from multiple angles and figure out what shape does it create. Okay, now we're going to do that same experiment with several different shapes. If you have your own Play-Doh at home, go ahead, take it out. That's what we're working with today. I did buy a whole bunch of Play-Doh for you guys to work with, but unfortunately I don't get to see you for a little while. Alright, so let me switch colors here. Alright, let's work with a pretty familiar shape here. Alright, it's a square on all 6 sides, but I do not call this shape a square. Alright, this is called a cube. It is important that you know what a three-dimensional shape is called because it is not the same when it is two-dimensional. Okay, so a cube is when it is 3D. Okay, this, when I cut it apart, can have a couple different shapes. So we saw with the cylinder, it could become a circle or it could become a rectangle. So most of the time when you cut a cube, it should become a square. So let's go ahead, let's find an example. If I take my cube, cut it right down the center. Voila, still looks like a square to me, right? Okay, if I put that back together, just kind of mush the sides together again, smooth it over with your butter knife. Okay, the way that I would not get a square is if I cut it on a diagonal, okay? This gets a little bit trickier to make a diagonal, okay, especially with Play-Doh and it's not something quite as firm. But if I get a diagonal, it's more of a stretched out shape, okay? So let's go ahead and try it. It is more challenging not to mush it up. Okay. This is not a perfect cut that I did. Okay. When I cut it this way, it should look like a rectangle. It should be a little bit longer one direction than the other. You should see that these sides are longer than top and bottom. But accidentally I messed up this corner a little bit. Okay. It should be a rectangle because it's going longer in the diagonal direction. Okay. Once again, it's not perfect because we had already cut it, tried to mush it back together. We are trying to cut something soft, okay? But you can play around with that as much as you want, okay? There are a couple different shapes. Now, another one that is tricky, I know we got out of taking the FSA this year for the 2020 school year. However, this could pop up on another test that comes up. If you take a cube, okay, try to smooth out your corners. Okay, this is one that they love tricking students on. Okay. They like to cut off just a little piece from a corner. If that happens, just a little edge here, that piece makes a little triangle, okay? That triangle is what always gets students, okay? I know the lighting is a little bit tough in here, but when they just cut off the corner, 1, 2, 3, that creates a triangle. That is the cross section or the two-dimensional slice, that it cuts off here. Okay, you can see it on both pieces. All right, let's try another shape. All right, this yellow one, some of us may just say it looks like a ball, maybe a potato. Okay, in math, we call this a sphere, okay? A sphere means it is basically a three-dimensional circle. And as you may guess, as we cut into it, the two-dimensional shape we would get is, you guessed it, a circle. So go ahead, cut in with your butter knife. I would not suggest doing this with any sort of sharp knife. Okay? You should find that you get a circle. Okay? Nothing too exciting should come out of there. I know I got a little bump in mine. Okay, it is Play-Doh. It is not perfect. I am human. Okay, nothing crazy will come out of your sphere. Okay, both sides make a circle. All right, moving on to another shape. All right, this one is a cone. Sort of looks like a Harry Potter hat or something like that, the sorting hat. Okay, this one could have a couple of different cross sections. All right, first of all, the base or the bottom is a circle. One way to tell what kind of cross sections you could get is look at the shape of the bottom or the base. Okay, if I cut parallel to the base, that means the same direction as the base. So if I basically sliced off the bottom, Okay, I would still have another circle. Okay, it's a little lumpy because it's Play-Doh, but see that? I still have another circle. Slightly smaller circle, but still a circle nonetheless, yes? Okay, and I could also cut it in the vertical direction. It's much more challenging because it is Play-Doh, it is soft, okay? It'll want to squish down. But if I cut it vertically, look at what shape it makes vertically, okay? It should slice down and make a triangle, okay? It looks like an ice cream cone. It will be a triangle, just like an ice cream cone shape would make. Let's see if I can do that with my knife without completely destroying it. Probably not. Oh, that may have been the most exciting moment of quarantine. I did not destroy it. Okay, so there we go. I have both parts of my triangle, or both parts of my cone. That became a triangle. Okay, so a cone can become either a circle or a triangle when you look at the cross section. Okay, so a circle is if you cut it parallel to the base, and then it'll become a triangle if you cut it vertical or perpendicular to the base. Let's try some more shapes. All right, this is a square pyramid. This is what you may see in Egypt. Not like we can leave our houses, but let's pretend. Okay, and I also don't know why it's green, but let's pretend. Okay, so once again, let's look at the bottom. The bottom shape is a square. So one of the basic shapes that you know it could definitely turn out to be is a square, because if I sat here and I cut off the bottom, you should still have a square, okay? Square, square, okay? That means one of the cross sections or one of the slices is a square, okay? Or looking at it vertically, once again, like the cone, if I cut it going straight down like that, I should still be able to get a triangle, okay? I don't know if I can do this twice without squishing my shape, but let's see if I can go 2 for 2. Well, I don't think so. Oh boy, that was exciting. Okay, I have 2 slightly lopsided triangles now, but yes, they should create triangles. Okay, that is assuming that you are going straight through the top point of the square pyramid. Okay, now there's an option. If you're not going directly through the point of the pyramid, if you're going a little bit further out, if you're going through this point of your square pyramid, you would make a trapezoid because you'd be cutting off the top pointy part of it. Okay, that's a little bit more complex to demonstrate, and I don't want to test my luck too many times. All right, I have one more shape to demonstrate for you guys today. All right, last but not least, this is one of our most mistakenly named shapes. Okay, this is rather lumpy, but it sort of looks like a tent, okay? A tent is not the technical name for it. This is a triangular prism. So a triangular prism means that its 2 bases or the 2 bottom sides are triangles. The 3 sides going around it are rectangles. So what we need to do with this now is we could slice it a couple of different ways. Once again, we could slice off the bases or the bottom like that. And voila, we could have a triangle cross section or a triangle slice. Or we could slice it this way and we could have a rectangle. this one doesn't want to cut. There we go. Rectangle slice. Okay. This one got a little, I cut the slice a little bit too thick, but that is a rectangular cross section or slice. So depending on the angle that we cut it, we have to pay attention, okay? So was I cutting this shape parallel to the base? That means parallel to the triangle, which would give me a triangular cross section. Or was I cutting it perpendicular to the base? That means going this way to the triangle, which would give me my rectangular cross section. Okay, depending on the direction will tell me which shape the cross section is. Okay, so those two vocabulary words, perpendicular and parallel, are going to determine which shape our cross section makes. All right, that's it for today's lesson, but tune in again tomorrow for some more. Thank you so much.